name is Adam Bradford. I'm an engineer on the VisionKit team. And if you're looking to add live text to your app, you are in the right place. But first, what is live text? Live text analyzes an image and provides features for the users to interact with its content, such as selecting and copying text. Perform actions like lookup and translate. Providing data detection workflows, such as mapping an address, dialing a number, or jumping to a URL. Live text even allows for QR code interaction. Imagine how you could put this to use in your app. You want to know more? Well, you're in the right place. For this session, I'm going to start with a general overview of the Live Text API. Then I will explore how to implement this API in an existing application. Next, I will dive into some tips and tricks which may help you when adding live text to your app. Now, for an overview of the Live Text API. At a high level, the Live Text API is available in Swift. It works beautifully on static images and can be adapted to be used for paused video frames. If you need to analyze video in a live camera stream to search for items like text or QR codes, VisionKit also has a data scanner available. Check out this session from my colleague Ron for more info. The Live Text API is available starting on iOS 16 for devices with an Apple Neural Engine and for all devices that support macOS 13. It consists of 4 main classes. To use it, first, you'll need an image. This image is then fed into an image analyzer, which performs the async analysis. Once the analysis is complete, the resulting image analysis object is provided to either an image analysis interaction or an image analysis overlay view, depending on your platform. Seems pretty straightforward so far, right? Now I'm going to demonstrate how one would add it to an existing application. And here's our application. This is a simple image viewer which has an image view inside of a scroll view. Notice I can both zoom and pan. But try as I might, I cannot select any of this text or activate any of these data detectors. This simply will not do. Here's the project in Xcode. To add live text to this application, I'll be modifying a ViewController subclass. First, I'm going to need an image analyzer and an image analysis interaction. Here, I'm simply overriding ViewDidLoad and adding the interaction to the image view. Next, I need to know when to perform the analysis. Notice that when a new image is set, I first reset the preferred interaction types and analysis which were meant for the old image. Now everything is ready for a new analysis. Next, I'm going to create the function we will use and then check that our image exists. If so, then create a task. Next, create a configuration in order to tell the analyzer what it should be looking for. In this case, I'll go with text and machine-readable codes. Generating the analysis can throw, so handle that as appropriate. And now finally, I'm ready to call the method analyzeImageWithConfiguration, which will start the analysis process. Once the analysis is complete, an indeterminate amount of time has passed, and the state of the application may have changed. So I will check that both the analysis was successful and that the displayed image has not changed. If all of these checks pass, I can simply set the analysis on the interaction and set the preferred interaction types. I'm using automatic here, which will give me the default system behavior. I think this is ready for a test. Oh, look at that. I see the live text button has appeared and, yep, I can now select text. Notice how these interface elements are positioned for me automatically and keep their position inside of both the image bounds and the visible area with no work on my part. Okay, notice that tapping the live text button will highlight any selectable items, underline data detectors, and show quick actions. I can easily tap this quick action to make a call and even see more options by long pressing. You have to admit, this is pretty cool. With just these few lines of code, I've taken an ordinary image and brought it to life. This simple application now has the ability to select text on images, activate data detectors, QR codes, lookup, translate text, and more. Not too shabby from just this few lines of code, if you ask me. And now that you've seen how to implement live text, I'm going to go over a few tips and tricks that may help you with your adoption. I'll start by exploring interaction types. Most developers will want automatic, which provides text selection, but will also highlight data detectors if the live text button is active. This will draw a line underneath any applicable detected items and allows one-tap access to activate them. This is the exact same behavior you would see from built-in applications. If it makes sense for your app to only have text selection without data detectors, you may set the type to text selection and it will not change with the state of the live text button. If, however, it makes sense for your app to only have data detectors without text selection, set the type to data detectors. Note that in this mode, since selection is disabled, you will not see a live text button, but data detectors will be underlined and ready for one-tap access. Setting the preferred interaction types to an empty set will disable the interaction. And also, a last note, with text selection or automatic mode, you'll find you can still activate data detectors by long pressing. This is controlled by the Allow Long Press for Data Detectors in Text Mode property, which will be active when set to true, which is the default. Simply set defaults to disable this if necessary. I would like to now take a moment to talk about these buttons at the bottom, collectively known as the supplementary interface. This consists of the live text button, which normally lives in the bottom right-hand corner, as well as the quick actions, which appear on the bottom left. Quick actions represent any data detectors from the analysis and are visible when the live text button is active. The size, position, and visibility are controlled by the interaction, and while the default position and look matches the system, your app may have custom interface elements which may interfere or utilize different fonts and symbol weights. Let's look at how you can customize this interface. First off, the Is Supplementary Interface Hidden property. If I wanted to allow my app to still select text, but I did not want to show the live text button, if I set the supplementary interface hidden to true, you will not see any live text button or quick actions. We also have a Content Insets property available. If you have interface elements that would overlap the supplementary interface, you may adjust the content inset so the live text button and quick actions adapt nicely to your existing app content when visible. If your app is using a custom font you'd like the interface to adopt, setting the supplementary interface font will cause the live text button and quick actions to use the specified font for text and font weight for symbols. Please note that for button sizing consistency, live text will ignore the point size. Switching gears for a moment. If you are not using UI Image View, you may discover that highlights do not match up with your image. This is because with UI Image View, VisionKit can use its Content Mode property to calculate the contents rec automatically for you. Here, the Interactions view has a bounds that is bigger than its image content, but is using the default's content rect, which is a unit rectangle. This is easily solved by implementing the delegate method contentsRect for interaction and return a rectangle in unit coordinate space describing how the image content relates to the interaction's bounds in order to correct this. For example, returning a rectangle with these values would correct the issue, but please return the correct normalized rectangle based on your app's current content and layout. ContentsRect for interaction will be called whenever the interaction's bounds change. However, if your contentsRec has changed but your interaction's bounds have not, you can ask the interaction to update by calling setContentsRecNeedsUpdate. Another question you may have when adopting live text may be, where is the best place to put this interaction? Ideally, live text interactions are placed directly on the view that hosts your image content. As mentioned before, UI Image View will handle the contentsRec's calculations for you, and while not necessary, is preferred. If you are using UI Image View, just set the interaction on the image view and VisionKit will handle the rest. However, if your image view is located inside of a scroll view, you may be tempted to place the interaction on the scroll view. However, this is not recommended and could be difficult to manage as it will have a continually changing contentsRec. The solution here is the same. Place the interaction on the view that hosts your image content, even if it is inside a scroll view with magnification applied. I'm going to talk about gestures for a moment. Live text has a very, very rich set of gesture recognizers, to say the least. Depending on how your app is structured, it's possible you may find the interaction responding to gestures and events your app should really handle, or vice versa. Don't panic. Here are a few techniques you can use to help correct if you see these issues occur. One common way to correct this is to implement the delegate method. Interaction should begin at point for interaction type. If you return false, the interaction will not be performed. A good place to start is to check if the interaction has an interactive item at the given point, or if it has an active text selection. The text selection check is used here so you will be able to have the ability to tap off of the text in order to deselect it. On the other hand, if you find your interaction doesn't seem to respond to gestures, it may be because there's a gesture recognizer in your app that's handling them instead. In this case, you can craft a similar solution using your gesture recognizers. Gesture recognizer should begin delegate method. Here, I perform a similar check and return false if there's an interactive item at the location or there's an active text selection. On a side note, in this example, I'm first converting the gesture recognizer's location to the Windows coordinate space by passing a nil and then converting it to the interactions view. This may be necessary if your interaction is inside of a scroll view with magnification applied. If you find your points aren't matching up, give this technique a try. Another similar option I have found to be useful is to override UIView's hit test with event. Here, once again, similar story. I perform the same types of checks as before, and in this case, return the appropriate view. As always, we want your app to be as responsive as possible. And while the Neural Engine makes analysis extremely efficient, there are a few image analyzer tips I'd like to share for best performance. Ideally, you want only one image analyzer shared in your app. Also, we support several types of images. You should always minimize image conversions by passing in the native type that you have. However, if you do happen to have a CV pixel buffer, that would be the most efficient. Also, in order to best utilize system resources, you should begin your analysis only when or just before an image appears on screen. If your app's content scrolls, for example, it has a timeline, begin analysis only once the scrolling has stopped. Now, this API isn't the only place you'll see live text. Support is provided automatically in a few frameworks across the system your app may already use. For example, UI Text Field or UI Text View have live text support using camera for keyboard input. And live text is also supported in WebKit and QuickLook. For more information, please check out these sessions. New this year for iOS 16, we've added live text support in VisionKit. AV Player View and View Controller support live text in paused frames automatically via the Allows Video Frame Analysis property, which is enabled by default. Please note this is only available with non-fair play protected content. If you are using AV Player Layer, then you are responsible for managing the analysis and the interaction, but it is very important to use the currently displayed pixel buffer property to get the current frame. This is the only way to guarantee the proper frame is being analyzed. This will only return a valid value if the video play rate is 0, and this is a shallow copy and absolutely not safe to write to. And once again, only available for non-fair play protected content. We are thrilled to help bring live text functionality to your app. On behalf of everybody on the live text team, thank you for joining us for this session. I am stoked to see how you use it for images in your app. And as always, have fun.